Lesson 19, Median Absolute Deviation. The median absolute deviation is a measure of dispersion, or variation of the data. The median absolute deviation measures dispersion by finding the value where half of the data is closer to the median and half of the data is farther from the median than that value. The median absolute deviation is denoted by the abbreviation MAD. The median absolute deviation is obtained by finding the median of the absolute values of the deviations of the data values from the median. The TI-84 calculator is not programmed to calculate the median absolute deviation for you. Nevertheless, the TI-84 calculator can be used to determine the median absolute deviation for a list of data values. For instance, calculate the median absolute deviation of exam scores for a student that receives scores of 4, 2, 5, 3, 0, and 4 for the 6 problems on their Unit 1 examination and interpret the result. So, in order to calculate the median absolute deviation, we can't use the TI-84 calculator directly because it's not programmed to do so. But we can indirectly calculate the median absolute deviation by doing the following keystrokes. First, we need to enter the data into a list. To enter data into a list, we press Stat and then Enter to enter the Edit menu. Now we select a list to enter the data in. For this example, we'll enter the data into List 1. Entering the data in one at a time, followed by Enter, we'd start off with 4 for the first exam score, Enter. And then a 2, Enter. 5, Enter. 3, Enter. 0, Enter. 4, Enter. Now I have all the Unit 1 exam scores for the student entered into List 1. To get out of the data editor, you press Second and then Quit. Second Quit takes you out of the list editor and brings you back to the main calculator screen where we can calculate things, such as the median absolute deviation. To calculate the median absolute deviation, we need to take the median. So the median can be found by pressing Second List and then using the right arrow to move over to the Math menu. The fourth item down that list is median. So press Enter to select median. Then we have to take the absolute value of the deviations. The absolute value is found by pressing the Math button and then right arrow to the Num for Number menu, and the first one, ABS, is for absolute value. So press Enter to select it. The deviations are the data values which were stored in List 1, so second 1 for List 1. Subtract. The median is the point of reference we use in the median absolute deviation. So we go back to the median by pressing Second List, arrow over to the right twice to Math, and then down arrow to the fourth selection, median. Enter. And it's the median of those data values we want. So we have to tell the calculator second 1 to get List 1. And now we need to close the parenthesis by pressing right parenthesis once, twice, 3 times, because we had 3 open parentheses. And then to get the result, we press Enter. So as we can see, our calculated median absolute deviation equals 1. Now that we've calculated the median absolute deviation, we now need to use words to interpret the result. Now, merely just stating the result in words is describing the result. So saying the median absolute deviation of exam scores for this student's Unit 1 examination is 1 is merely just a description. An interpretation gives meaning or explains this result. The median absolute deviation finds a value such that half of the data values are closer to the median than that value, and half of the data is further from the median than that value. So here's an interpretation. Thus, half of this student's Unit 1 examination scores are closer than 1 to the median, and half of these scores are farther than 1 from the median. To illustrate this, we could take the student's Unit 1 examination scores and display them on a number line. Now, in a previous example, we have already calculated the median for these data values. That is, the center divider, where half the data is less than and half the data is more than, was 3.5. So the median is our point of reference in the median absolute deviation. With a median absolute deviation of 1, this tells us that if we go 1 median absolute deviation above the median value of 3.5, that would get us to 3.5 plus 1, or 4.5. And if we go 1 median absolute deviation below the median value, we would take 3.5 minus the 1 and get to 2.5. So within this range, from 2.5 to 4.5, you'll see that half of the data values are closer to the median than this median absolute deviation value. That is, the values of 3, 4, and 4 fall within the median absolute deviation of the median. That is, within the 2.5 to 4.5. The other half of the data values, the 0, the 2, and the 5, fall farther from the median than the median absolute deviation. So 3 out of the 6 scores, or 50%, fall within 1 median absolute deviation of the median, and the other half, 3 out of 6, or 50%, fall further than 1 median absolute deviation from the median. As with the median absolute deviation is resistant to outliers, that is, extreme data values. So when outliers are present in the data, the median absolute deviation, or MAD, is the preferred method for measuring dispersion.